Let's look at this scenario where you have a cart that's going down two inclines or down a hill, and let's look at different states. The first one we're going to do is this one here, which is energy at point A. So this is when the cart is sitting completely at rest. So let's imagine the initial velocity was 0 meters per second, so it's just sitting at the top. So we're going to have energy potential plus energy kinetic. So let's think about that. Does it have any kinetic energy at the top? Nope. So now we have is equal to mgh. So we have 200 kilograms times 9.8 times the height of 20 meters, which gives us 39,200 joules. All right, let's look at point 2, which is the energy at C. So C is over here. Now the cart's going to be at this stage, and it's still moving, but it has some kinetic energy and some potential energy. So remember, the conservation of energy states that energy potential initial plus energy kinetic initial is equal to energy potential final plus energy kinetic final. So at this stage, we have no, let's think about it. It has some initial kinetic energy and some initial potential energy. Well, actually, it has no kinetic energy initial, but it does have a state of kinetic energy and potential energy at this stage. So let's just write mgh, height initially, is equal to mgh final plus 1/2 mv squared final. So you notice that all the masses cancel out. So you get 9.8 times initially it was at 20 meters is equal to 9.8 times it's now at 10 meters plus 1/2. At this stage now it has a mass of, a velocity that we're not too sure of, squared. So let's look now at 9.8 times 20, which is 196 is equal to 98 plus 1/2 v squared. So if we subtract the 2, you get 98 and we got to double it, times 2 is equal to v squared. So v is the square root of 98 times 2. So we're going 14 meters per second at point C. Now the problem did ask us actually what was the energy at point C, and the fact is that it's got a combination of potential energy and kinetic energy. So here our velocity is 14 meters per second, and it has the same total energy at this stage as it has at this stage. At all times it has the same total energy. Even at the energy here is the same, so no energy is ever lost. Let's look next at, let's look at velocity at A. So for number 4, there's no velocity because it doesn't is currently not moving, so V at A is equal to 0. All right, and down at the bottom here, number 5. What's the velocity at point E? So down at this point here, so we could do the same equation again. So we know the total potential energy So we know the system energy as a whole is 39,200 joules. And it must equal the final energy. So at the bottom it has no potential energy, it just has kinetic energy. So let's rearrange that. So we have velocity squared is equal to 39,200 joules times 2 over the mass, which is 200 kilograms. So we get 392, and if we take the square root, our speed at the end is 19.79 meters per second. So right here, our velocity is 19.79 meters per second. So just a couple ways to think about it. It has the same energy at all stages, just the energy transfers.